But there's something more that sets us apart. Courageous chemistry.
Hello, welcome to today's lesson. In today's lesson, we'll look at electrolysis of some common compounds. Okay, remember in our last class we said ions are forming what? Solution, is it not? And we also looked at the terms in what? Electrolysis. In today's lesson, we'll look at the process of electrolysis. But first, we need to learn an important term known as electrochemical series. Now, electrochemical series is actually a list of cations and anions in order of their reactivity. It is also called activity series. Okay, now these elements are arranged based on their standard electrode potentials. Okay, generally those at the top tend to displace those at the bottom. Now it finds a very wide application in chemistry. For example, in electrolysis, during this process, the ions that are below the series tend to be easily more discharged than those that are above the series. So as you may have, for example, potassium ion and lead ion in solution, lead ion will be discharged compared to what? Potassium ion. Similarly, if I have sulphate ion and hydroxide ion in solution, hydroxide ion will be what? Discharged. Except in cases where I have something like chloride ion and hydroxide ion, and the concentration of chloride ion is very high, which we will learn shortly. Okay, but take note of the electrochemical series and learn to memorize them. Okay, let's now look at the first electrolysis process today. It's electrolysis of acidified water. By acidified water, we mean water that we added dilute or concentrated what? Acid. Example is sulfuric acid. Okay, now we'll set up our apparatus as usual. Okay, wherever we connect the positive terminal to, we'll call the anode, and wherever we connect the negative terminal to, we'll call the what? Cathode. Take note of it. Okay, you can see here that I'm using a graphite electrode. If you use a platinum electrode, we'll still have the same result because both of them are inert. So a graphite electrode and a platinum electrode will give us the same result for the electrolysis of acidified water. Alright, my electrolyte, of course, is now acidified water. Acidified water now contains sulfuric ions, hydrogen ions, and then hydroxide ions. Is it not? Yes. Now, during this electrolysis process, my water is going to dissociate into two substances, which are what? Hydrogen and what? Hydroxide ion. Similarly, my sulfuric acid is going to dissociate into hydrogen ions and tetraoxosulfate 6 ions. So we have hydrogen ion and sulfate ion. Yes. Now, migration will begin. Is it not? As electrons enter from the cathode, migration will begin. All the cations or the positive ions will migrate to where? To the cathode, while the negative ions or the anions will migrate to the where? Anode. Preferential discharge is what we now need to consider. Is it not? Yes. Remember, I told you from the electrochemical series that ions that are below the series tend to be discharged during the electrolysis process. Is it not? Yeah. This means I have only one set of cations, hydrogen. Is it not? Or I have two sets of what? Anions, which are what? Hydroxide ion and what? Tetraoxosulfate 6 what? Ions. Is it not? Yes. So now we're going to carry out preferential discharge. Of course, my hydrogen will move straight to my cathode. Is it not? Since I have only one cations, and you know the cathode is rich in electron, so they will be reduced from hydrogen ions to what? Hydrogen gas, as seen in this equation. And then I have to now consider my electrochemical series, knowing fully well that I have sulfate ion and hydroxide ion, and I know that ions below the series tend to be discharged during electrolysis. Therefore, my hydroxide ion will now be discharged at the what? Anode, as shown. So here, my anode, the hydroxide ion donates its electron at its oxidation. Is it not? Yes. Remember oil rig. Oxidation is loss, reduction is gain. Okay. I remember cathode, red cat. Red cat means reduction is at the what? Cathode. Therefore, oxidation is at the what? Anode. So it donates electron as shown, but remember it's just a single what? Hydroxide ion. So we have multiple hydroxide ion up to 4 donating what? Electron as shown. Overall reaction, you will now have 4 OH minus, giving you what? 2 molecules of water and 1 molecule of what? Oxygen, with the release of 4 electrons. Alright, you can see clearly that my left cathodic or reduction reaction is not balanced with my right anodic or oxidation what? Reaction, because of difference in what? Electron supply must be equal to electron gain. So to do that, I simply multiply my cathodic reaction by 2, is it not, to balance the electron. And then at the end of the day, I will have
4 atoms of hydrogen ion, okay, accepting 4 electrons to form 2 moles of hydrogen gas. Is it not? Yes. Now that the equation on the right is now balanced with the equation on the left, we can now, due to the electron balance, we can now write the overall reaction by bringing everything to the right on one side, everything to the left on one side, and cancel out electron. You know these ones already, is it not? Yes. So in conclusion, we can say that the electrolysis of water yields 3 products. At the cathode you have hydrogen, while at the anode you have what? Oxygen. Now, if we go back to the electrolyte solution, the nature of the electrolyte solution depends largely on the concentration of the acid and the hydroxide ion present as well. Since we are using dilute acid in this case, the overall solution might end up becoming neutral, okay? However, if we have more of the hydroxide ion, then it might end up becoming what? Basic. And if we have a concentrated acid, then the whole electrolysis process might take a longer time before the solution becomes neutral, okay? Take note here that the volume ratio formed between the hydrogen and oxygen is 2:1. All right? Let's now look at electrolysis of dilute sodium chloride and also concentrated sodium chloride, which is also called what? Brine. First of all, identifying our electrode. Our electrode we're going to be using in this one is platinum electrode, okay? Remember, platinum electrode is also an inert electron, is it not? Yes. Now, we identify our ions in solution. We are going to have 2 cations and 2 anions, is it not? We're going to have sodium and what? Hydrogen, is it not? Yes, as a cation. So our anions will now be what? Chloride and what? Hydroxide ions, is it not? Now, we'll go back to our electrochemical series again. Preferential discharge. Hydrogen will be discharged over what? Sodium. Why? Because sodium is more stable, is it not? Yes. At the what? Cathode. Why? At the anode, hydroxide ion will also be what? Discharged. Why? Because chloride ion is more stable than what? Hydroxide ion, is it not? Yes. And that leaves us with the same electrolysis as that of acidified water, just now, is it not? Yes. So we have 2:1. And then our electrolyte solution now still contains what? Sodium ions and what? Chloride what? Ion. In other words, the electrolysis of this dilute sodium chloride will cause the dilute sodium chloride to become a concentrated sodium chloride. The pH remains constant. Why? Because both the hydrogen ion and the hydroxide ion are constantly what? Being used up. Is it not? Yes. For emphasis, we'll now look again at the overall reaction as usual. Is it not? Yes. So you have 4 moles of hydrogen combining with 4 moles of electron to form what? 2 hydrogen gas. That is at the what? Cathode. And on the anode, you have 4 hydroxide ion releasing 2 molecules of water and 1 mole of what? Oxygen gas plus 4 electrons. What do? You combine anode plus what? Cathode, is it not? And you cancel out what? Electrons to give you what? 4H plus 4OH minus to give you 2:1 in terms of hydrogen and oxygen, is it not? Yes, take note of that. So it means that for every 100 cm³ of hydrogen gas produced at the cathode, 50 cm³ of oxygen will be produced at the what? Anode, is it not? So we can conclude that the hydrolysis of dilute sodium chloride yield 2 products: hydrogen at the cathode and oxygen at the what? Anode, in the ratio 2:1 respectively, is it not? Yes. And also the solution or the electrolyte becomes more concentrated due to the what? Removal of what? Water, is it not? Yes. Now you must take note that we do not make use of mercury electrode during this process because it interferes with what? Sodium. Sodium have strong affinity for mercury. In fact, the electrode will end up forming amalgam, as you can see there, with the what? Sodium. Take note of that. It is very, very what? Important. Let's now move on to the electrolysis of concentrated sodium chloride, which is also called what? Brine. In brine, we have more concentration of the sodium and the chloride ion than the hydrogen and the hydroxide what? Ion. So what do you think is going to happen during the discharge when the potential difference is set up? Chlorine at the anode will be discharged. Why? Because the concentration of chlorine is way higher than that of what? The hydroxide ion in this case, okay? So chlorine will be discharged. Check again in your electrochemical series, you'll find out that they are still a bit close to each other. Hence, it is affected by the concentration, unlike the other side where sodium is still far from the hydrogen. So the case will remain the same. Hydrogen will still be discharged at the what? Cathode, okay? Because chlorine is way more too stable and is way too far from the what? hydrogen. Do you get it now? Yes. This implies that our electrolyte will now contain sodium and hydroxide ion, is it not? This will now combine to form sodium what? Hydroxide. So the overall process is causing the pH of the solution of the electrolyte to change to what? Basic. Do you get now? Since there is more of what? Hydroxide what? Ion in the what? Solution. So the ratio of the product form is 1:2:1. Okay, 1 mole of hydrogen, 2 moles of sodium hydroxide against 1 mole of what? Chlorine gas. For emphasis, then you can take down the equation. You can see the equation at the cathode, of course, hydrogen undergoing reduction to form hydrogen gas, while the anode, chlorine, undergoing oxidation to form chlorine gas. Let's now compare the electrolysis of both dilute and concentrated sodium chloride. All right, in terms of their concentration, we know for dilute it is low concentration of sodium and chlorine, while for that of high it is of concentrated sodium chloride is high concentration of sodium chlorine. In terms of their cathode discharge, it is the same, hydrogen. While for anode you have oxygen discharge for dilute and chlorine being discharged for concentrated. And of course you can see the ratio of their products there, is it not? Yes. Electrolysis of copper 2 tetraoxide of 6 using platinum what? Electrode. Now when we carry out this electrolysis, as usual, we are going to have 4 ions, is it not? Yes. We have the sulphate ion, we have the copper 2+ ion, we have the H+ ion and the OH- ion, is it not? Yes. And then when potential difference is set across the terminals of the cell, of course, the positive ion will migrate to the where? Cathode, is it not? While the negative ion, which are the anode, will migrate to the what? Anode. Which of them will be discharged? You go back to your electrochemical what? Series. Your electrochemical series, you discover that copper is below hydrogen. Hydrogen is above. In other words, you can say hydrogen is now more stable. Therefore, copper will be what? Deposited at the what? Cathode. That is, copper will be reduced. Is it not? Yes. Why? On the other hand, you have sulphate ion and OH- ion. You can see the gap is very far, is it not? So OH- ion will be deposited at the where? Anode, is it not? Yes. That is, oxygen will be what? Giving up as what? Bubbles. Take note of that. So this is our half equation. You have Cu2+ plus 2E- to give you copper reduction at the cathode. And the oxidation, you have 4 hydroxide ion forming water and oxygen with the release of 4 electrons. As usual, we'll balance our charge, is it not? Yes, by multiplying by 2. So we have 2 Cu2 plus 4E- to give you 2 Cu. Now we can now write both half what? Equation and cancel out what? Electrons, is it not? Yes. We do that. You have 2 Cu2 plus 4E to give you 2 Cu. And then the other one, you have 4OH- plus 2H2O plus O2 plus 4E. 4E cancel 4E. And then you are left with 2 Cu2 plus 4OH- to give you 2 Cu plus 2H2O plus O2. Now, our electrolyte will now become what? Acidic. Why? Because our electrolyte now contains hydrogen ions and sulfuric what? Ions. And we know hydrogen ion are responsible for what? Acidity, is it not? Yes. Electrolysis of concentrated copper 2 tetraoxide of 6. Now, we have that this solution is concentrated. That is, you have more of the copper ion and the sulfate ion than the what? Hydrogen and the what? Hydroxide ion, is it not? Yes. Still, you end up having the same result. Why? Because we know that now we now have more of copper. You know, copper naturally is supposed to be deposited because it's lower, is it not? Yes, than hydrogen. But on the other hand, you're having more of sulfate ion, that is tetraoxide of 6 ion, than the what? Hydroxide ion. But still, the hydroxide ion is going to be deposited. Why? Because the distance between the sulfate ion and the hydroxide ion in the electrochemical series is very what? Far. Therefore, the concentration will not affect it. So we still end up having the same result as the electrolysis of what? Copper 2 sulfate earlier. Okay? You have the same equation, the same product. The solution will also be what? Acidic, because of the presence of what? Hydrogen. Is it not? Yes. Let's now look at when we carry out electrolysis of copper 2 sulfate. This time we're not using an inert electrode like platinum. We are using an active electrode, which is what? Copper. Here, when the battery is connected, the dissociation will take place because of the movement of electrons. Ions will be formed. The positive cations of copper will migrate to the cathode because of preferential discharge, is it not? Yes. But at the anode, neither the hydroxide ion nor the SO4 ion will be deposited. Why? Because the electrode is made of copper. So as copper ions are leaving the electrolyte, copper ions are also entering the electrolyte from the where? Anode. Is it not? Yes. The net reaction is going to be the physical change you will see is that the mass of the anode will be decreased. The size of the anode will decrease, while that of the cathode will increase because of the movement of what? Copper ions from solution to the cathode and from the anode into the what? Solution. I think you understand what I'm saying. In a more simple term, it simply means that copper is leaving the electrolyte into the cathode, while copper is being removed from the anode into the electrolyte. This process is very important because it is used in extracting metals and also purifying what? Metals. It is also used in electroplating, is it not? Yes. Now, the evidence is very clear in your eyes. Can you see now that the deposited copper has made the cathode to become bigger in size, while the lost copper has made the cathode to become what? The anode to become what? Smaller in size. That brings us to the end of today's lesson. Stay safe, do your activities. I'll see you soon.